Thank you for coming. Thank you everyone who's enthusiastic about teaching Scala. There's been a lot of talks about teaching Scala at Scala Days, which is wonderful. And for people watching the video, I don't know if you can point the camera at the 2,000 people in the room today. This is wonderful. Thank you. We have people flying from Uruguay just to watch the Scala Days. Anyway, so my name is Alejandro. I currently work for Shopify. And apparently I have to say that this is my own personal project, not a Shopify project. But thanks Shopify for sending me here and being at the conference. So today I want to talk to you about ScalaQuest, which is a game we're building to teach people Scala. Okay? Anyway, when I say we, I'm talking about these handsome fellows there who couldn't be here on the stage talking to you about the game. I'm the lucky one that gets to do that. So I want to start by stating why I think you should care about ScalaQuest. So these are the things that drive the project per se. People want to level up their Scala, of course. And you, if you're in Scala Days, you probably know enough that a lot of the basics we'll be teaching already pretty good for you. But you are part of teams that want to learn Scala. You want to onboard people. You also want to encourage people outside of your companies or your communities to have easy ways of onboarding Scala. And we have a number of really great resources out there. We have books, of course. We have folks that Underscore have created Scala. There's Scala Bridge. But people learn in different ways. So this is a different proposition on how I think we can learn. Personally, I love this project for a number of reasons. I've been teaching Scala for quite a while. Professional courses with Lightbend, at the companies I've been a part of. But I've been just teaching for many, many more years. I've always loved the experience of being with someone when they go through those aha moments. When they don't know something and you sort of facilitate it for them and they sort of start to go, oh, that's a really cool thing. So when you're part of that process, I think that's really cool. And personally, I learned a ton of stuff by playing games. And one of them, which is really important for me, was the English language. This was the single thing that pushed me to learn English, playing Zelda. I got that game when I was a kid, and I started playing, and I got to this. I knew no words in English, so I go to my dad, and he would help me out. And he helped me out for the first 5 or 6 or 7 times, and then he gave me a dictionary and said, off you go. The cool thing about it, though, is that when I was going through this, English didn't seem like homework. It was just something it was part of the experience. It was part of the game for me. Even though the creators of Zelda didn't think about this, but for me as a non-English speaking person, I was like, yeah, this is just part of the challenge, right? So, and of course, many other games taught me different strategy thinking and all that. And when reflecting about that, I thought, well, fun is kind of this multiplying element, a multiplying factor in learning, right? When you're having fun, you're more engaged, then you're paying more attention, you're not as easily distracted. So I thought, well, this is sort of like an important thing for me, right? Turns out I wasn't the first one to come up with this idea. So Albert Einstein said, play is the highest form of research. And I'm pretty sure he was talking about the Zelda series of games when he said that. Oh, by the way, you can take that quote back home, and whenever you're caught playing games at work, just say, I'm doing research. Einstein said it. Anyway, and of course, there's a whole industry area of people who want to use games for other things more than entertainment, right? So the whole area of serious games and educational games. And I'm hoping to bring a little bit of those ideas into the world of Scala. How many of you have read or know of the book called Flow? Okay, a few of you. I'd really encourage you to read it. It's a really interesting book. And it talks about sort of that feeling we get, and sometimes we call it flow, or sometimes we call it being in the zone, right? When you're doing something that is not too easy, but not too hard. It's the right level of difficulty for you, and you have some motivation to actually push through, right? So I think this quote actually summarizes the main idea very well. The best moments usually occur when a person's mind and body are stretched in a voluntary effort, you have to want it, to accomplish something that is difficult and worthwhile, right? You're actually putting an effort. If it's too easy, then you get bored and you go away. If it's too hard, you get really frustrated and it's hard to learn anything. But there's sort of this area that has the right amount of difficulty, where you're just motivated to keep going because we like the challenge, okay? Well, turns out that learning Scala is difficult, and if we're here, it's probably worthwhile for all of us. My challenge is, can we make it fun? so that people use this multiplying factor of being really engaged while learning things that might be hard for a lot of us. Okay. So with that, a bit of a story. This is Juan X. And Juan lives in this place called Dataland. And in this place, people harvest data manually, or they used to, before the upcoming of these computer things. So computers appeared, and with them, just like we have gravitational forces and electromagnetic forces, these weird forces started to appear in Dataland. One was called Fortran, C cross cross. Some of you might have done a little bit of work on this force, or Java. Oh, Java had a really cool feature, which is as you're harvesting, there was waste that got generated. It actually collected it for you. Pretty cool. Came with a module called garbage collector. All these things made data more efficient, and for a time things were good. But as the usage of these tools grew, complexity plagues appeared. And then you ended up with things like, it might be hard to read there, but I'll read it for you. It's going to take a while. Abstract, singleton, proxy, harvest, factory, bean, and nobody could read this. We don't know what that is. So in Dataland, this powerful magician called Ski had roamed Dataland for a long time and had tamed many, many forces. And he actually discovered one in particular that he called Scala. Now, Ski, knowing that Scala was a really powerful force, he wanted it to be yielded wisely and skillfully. So he set about to create an order of apprentices. And he called this the Order of Ski. Some call it Order Ski for short. Thank you. I worked on that joke for like an hour. Thank you. Anyway, so let me show you a little bit of ScalaQuest. So we had a Kickstarter project last year, which was successful. And this is where we are now. What is harder than playing a game is playing it when the screen is behind you. Anyway, so this is ScalaQuest. I'm showing you level 3. So on level 1, it's very basic. You go around the map and you're collecting items. And as you're trying to collect them, you're actually presented with questions that you have to answer by writing Scala programs. Whereas here, we've gotten to a place where we actually collected a wand. And this wand allows us to shoot at these little goblins here. There we go. That's satisfying, eh? Again, we work on that sound for like a week. Anyway, and as you go around, you encounter NPCs, you encounter enemies, and some of these guys are sort of blocking your way, and you want to go around and make more progress. So then you explore, and then you find, oh, it's going to be hard. You've got to use the mouse. There we go. So as you go through things, you have to answer Scala questions, right? And some of them, and this is one of the sort of like teaching mechanisms we use. We call this micro challenges, questions that have very, very simple answers. It might be a one-liner, very short. It might be just multiple choice, A, B, C, and D, et cetera. Okay? And the idea here is that we're giving you very, very small bits that you can action on, right? So you could sit down and play for 15 minutes, 20 minutes, and then you go home, and we keep going, okay? But we also have sort of more elaborate challenges where you're writing a larger sort of solution, okay? And that bit is important for something I'm going to talk about later. Okay. So, I do that. There we go. Okay, so that's just a tiny, tiny bit of the game. And I'm going to do something horrible here. I'm going to break the barrier, because I just realized my computer is at 18% battery. I am certain it's going to die. So I'm going to try to continue talking as I do this. So I just showed you just a very small snippet of what the game is like. And now I want to talk a little bit about sort of like the interesting technical challenges we encounter when building the game, okay? So like I said, we had a Kickstarter last year that gave us some funds to move on. We have 3 levels that are playable right now. We're working on level number 4, and we're hoping to have a public release in the next few weeks. So we're really, really close to having this out for everyone to take a look and play. Now, what we've built here is an application that runs in your browser using a framework called Phaser.js. I see a couple heads nodding, so maybe you've seen this before. It's a cool framework, but it's JavaScript. So, as good as it can be. The backend is a play application. Okay, and right now the play application is actually quite small. I'll talk about a couple interesting bits in there. Now, those tiny little challenges that I mentioned, all of those are small enough that they're evaluated on the client side. So we're using regular expressions to evaluate those. And regexes are great, but they're really limited in what we can do, right? So the questions has to be phrased in a way that there really is 1 or 2 or 3 solutions, and we can validate those, okay? But we have more interesting challenges where we give you a lot more freedom. You can write a lot more code, and of course, those cannot be evaluated using regular expressions. So we actually do send your code to the backend, needs to be compiled, and we come back. We also write for all those exercises, we have unit tests, so we can validate that your thing not only compiles, but is correct, okay? So there are 3 things I wanted to mention in terms of interesting challenges that we've encountered when building this. One that has to do with how we define those levels, how we are keeping user state, and how we compile that code that people send to us, okay? And this is also some of the progress we've shown since last time we did this talk a year ago. So the first thing is, Phaser gives us the ability to write levels, right? We have a number of sort of primitives in here. And when you create a level, there are a few basic things you have to figure out. Well, what's the size of your level? How many pixels, tall and wide, do you want it to be? What are the tiles you're using? What's the background? What are the background images you want to use for those? What are some of the items that are there, right? So those gems and that player and the door are things that not only background images, you want to interact with those, right? We have sounds and we have animations. So all these things are sort of the basic building blocks that we need in order to put together a level. Now following the examples on Phaser.js and the community, we started by defining all those things in JSON files, plain handcrafted JSON files. And that was fine for level 1, and that was fine for the beginning. But we quickly ran into issues with writing these things manually, right? So it was like a pretty obvious candidate for an improvement. Can we do better than just writing these things manually, okay? So we're Scala developers. So we created this data model on the back end where we defined, so now all the level definitions are in the back end. So we created a number of classes that represent all those primitives. In the process of doing that, we caught a whole bunch of bugs, of course, that were dormant, and we hadn't actually figured those out by playing the game. So pushing that data model back saved us, I don't know how many lines. I don't have the numbers, but we had something like 3,000 lines of JSON that was handcrafted, and now we have a couple hundred lines in Scala. Okay? So serialization for all of this was trivial. We're using play, so we just use the play JSON library. And all the errors we found once we did this were about, again, bugs that were dormant and we hadn't found before. So this was a clear win for us. So like I said, the good thing is now serialization happens for us. Whatever changes we had to do on the front end were actual bugs that we had to fix. Okay? And this is one of those rare situations where there was a whole bunch of good and 0 bads. Like there was no pain in doing this, and it was sort of win all over. Okay? Now, the next thing I want to talk to you about is, well, what about you start playing the game, you go around, collect a few gems, and then you go away. You log out, or you close your browser and come back. How do we keep all that state? Right? So again, our play application is very, very small. It's very simple. It's delegating to these level definitions, and most of our code is in JavaScript. But we obviously need to keep the state of the user. How far have they gone? What levels or what items they've interacted with, collected, et cetera. So in looking at this, we found that this was a perfect candidate for event sourcing. Because as the player is going through the game, we're just firing events to the backend. And all those events, and the backend has the responsibility to figure out which of those events are relevant for a current state. Right? So for example, you start on level 1 and you're, let's say, beside the main door. And you walk around, do nothing else, you walk around, and then you close your browser. When you come back, it's fine to start at the initial position, right? So the events that have to do with where you walked are not particularly relevant for a state. But if you finish some micro challenges and collect an item, obviously those are important. Next time you come back, we want that item to be collected, whatever that means for us, okay? So we chose to go event sourcing with this. We used Docker persistence. Who's ever done event sourcing with Akka persistence? A couple of you. So I'll show a couple examples which hopefully are interesting for you folks. And what happens here is that for each user that's currently using the application, we spin up a new Akka actor, and that actor is then responsible for storing, or for keeping level, and storing whatever events are meaningful. We're using the plugin to persist to DynamoDB, and this was painless, very easy to set up. It's worked great so far. Oh, and this is important. And this is not particular to Akka persistence or to DynamoDB, but whenever you're using event sourcing in general, you have to think about what's the evolution of your data model. Anything that you're persisting, you have to think about whenever your model changes. If you add a new field, you add a new object, you add a new set of values, what's going to happen next time you load events that were written using your previous model, right? So the evolution of your data model is really important here. Do I migrate all of the existing data, or do I create adapters that can read sort of these legacy event data types and move it into the newer version? Okay, so version of your data model is important here. So let's see if we can go through a couple code examples here. So the idea here, if you've never worked with an actor, the one-liner is this. An actor is an object that can process messages and that lives inside this environment where it's safe to do mutability and effects. Okay? That's sort of the elevator pitch. So imagine we're inside an actor as this object that is sort of in memory, it's working, it's processing messages. In our case, we're doing event sourcing, those messages are events. So we expect them to be game events. Okay? So somewhere in here, you have this receive thing, and that receive is what gets called or invoked whenever a new message comes in. So here we've created our own object called event parser. It'll take that string, which is going to be a JSON coming from our JavaScript application, and that thing represents some kind of game event. Again, you open a door, you collected an item, you finish a challenge successfully. And then we do this, and this line in here is very, very important, because this is where we say, okay, we've found an event that we recognize. We want to, first of all, persist that thing. So here, persisting happens first. As soon as you get an event that you recognize as valid, you save it. And after this is saved, then you can update your own state, the state of this one actor. Okay? Now, part of the magic in here in the update state is there's a discrimination between which events are actually meaningful for my current state and which ones are not. I'll give you an example. Some of the events we collect, we know we're going to want them to do sort of statistics or to understand user behavior later. When you start a micro challenge, you might try and fail 2, 3, 4 times before you actually succeed. Well, right now in our game, we only care about the successes. You move forward when you succeed. But we're actually recording all those failures because we later want to understand user behavior and go, well, in this particular question, people are getting a lot more failures than the rest, right? So to find sort of these abnormal behaviors. Maybe the question is not phrased well. Maybe there's a bug in how we are actually checking the solution, okay? So this is where you discriminate between events that are actually meaningful for your current state versus the ones that are not. Okay, so with that, and this is the update state. And again, this is where, with pattern matching, we decide which one or which events are actually meaningful, which ones are not. Okay. Okay, so I think that's all I'm going to say about that. Actually, no, a couple more things. So the idea here is when we persist, we're actually telling Akka persistence, take this object, save it somewhere, whatever the configured plugin or the configured method for serialization is. So in our case, that goes to DynamoDB. Okay? And then the other thing is Akka persistence takes care of everything that has to do with rehydrating that actor when he needs to be alive again. right? So Akka is highly configurable, and you can say, well, keep these many actors alive or whatever, right? So in our application, we don't have to worry about those actors sort of being in memory, right? Akka Akka takes care of all those details for us, okay? Which is pretty cool. Okay, so that was thing number 2. Thing number 3, which has occupied quite a bit of our time lately. Again, some of those challenges we checked on the client side. Those are the easy ones. The tougher ones, which is where a lot of the learning is going to occur, we actually need to take that code and compile it. Okay? So we need to take code that you've submitted and actually compile it on our backend. Okay? So we evaluate a number of different solutions on how to do this, right? So we have, of course, the ability to compile code in the backend, but what does the architecture look like for that? So we needed something that was, of course, inexpensive. So this is a garage project. We don't have a lot of money to spend. We need something scalable, because clearly we're going to have billions of users for this game, right? Thank you. Thanks for the optimism for those who laughed. But we need something that can scale, right? We know that compilation is hard. Compilation takes a lot of CPU time. So we need to make sure that's not affecting the rest of the performance in our game, right? Security, of course. So code can be malicious by intent, or it can be unintentionally buggy, right? So we're going to process code that we don't know is actually safe. So we need to make sure that actually is taken care of, okay? Which is why we ended up with Amazon Lambda. Parenthesis here. I think it's a really sad state of affairs that when you Google Amazon, you get a ton of results about Amazon.com and none about the powerful Greek warriors, right? There are at least 2 Amazons that I can think of that are a lot more important than Jeff Bezos. This is one, right? The other one, the big Amazon River in South America. So I actually had a second parenthesis. I had an idea when doing this about a plugin for your browser that just once in a while gives you results for your search engine of results that actually matter, right? So if you Google Amazon, you get this instead of Amazon.com. Anyway, let's go back on track. So we looked at a number of alternatives, but Amazon Lambda have a few things that were really attractive for us. One is that, of course, Amazon Lambda can run any JVM app. By the way, I should ask, who's worked with Amazon Lambda before? Okay, so a few of you. Again, the one-liner for Amazon Lambda is that you push something up to that infrastructure that looks like a function, hence the name Lambda. It has an entry point and it has some kind of result. And it's run in this very isolated space, right? And the way it works is you push a Java application that has a main method, an entry point, that will process requests, right? So you can wire that to a number of different connectors, one of them being an HTTP connector, right? Okay, so an Amazon Lambda can run any JVM app, also Node.js, but we don't care about those right now. We can pack a compiler in that application, of course, which is what we've done. But more importantly, that Lambda is very, very restricted on what it can do, right? So it has no disk storage to screw up. You can limit connectivity as much as you want, et cetera, right? And more importantly, if one dies, there's a whole bunch of others that can be spun up. So you can configure, you have fairly fine-grained configuration on how you want these to behave. You typically, because there's some warm-up sort of period when you bring up an Amazon Lambda, you want it to stick around for a while. If it's not used in a few seconds, then you bring it down. But you can configure how many of these things you want, right? And again, how to configure this is actually fairly easy. So this actually fit our model very well. We found, however, that packaging and uploading a Scala application to Amazon Lambda was less than trivial. So we actually spent a few cycles figuring out exactly how this was to be done. Ran into a ton of issues with class loaders whenever we were trying to do reflection in there. But anyway, we sort of over that hump now. So we do have We were able to now have an Amazon Lambda that can compile user code. This was largely the work of Mauricio, one of the handsome fellows you saw at the beginning, and he's published sort of a distillation of that into a small GitHub repo. So if you're ever interested in doing something like that, I encourage you to take a look, and you'll save 2 or 3 days of work on figuring out the details. Okay? So this is great, because this gives us now a model where our Play app is very lightweight, does very little work, so we'll have a couple of nodes there just for redundancy, because we only really need one, right? Even for the billion users that we'll have. And we have the compilation, which is the hard work, sort of separated into an Amazon Lambda. Okay? So that's sort of the state of affairs for ScalaQuest. Again, we're working on level 4 now. We'll be publishing something very, very soon, the next few weeks, for everyone to try out. Stay tuned if you think this is a cool project. Follow us on Twitter or on mailing lists. People apparently still do mailing lists, right? So take a look at scalaquest.com and you can follow us there. Okay? And that's all I have. I think I'm a little early. So if anyone has any questions, I'm happy to answer those. Thank you.
Did you consider using Scala.js instead of Amazon Lambda? I'm especially thinking of Scala Fiddle, which has an extremely fast compile and run loop.
Yeah, we definitely.
Alejandro, can you repeat?
I'll repeat it. Okay. So the question is whether we consider using Scala.js, and as an example, Scala Fiddle, who does something similar. Yes, we did. We decided against it for very practical reasons. This project has one full-time developer who knew 0 Scala before this project. So it was hard to have him also learn Scala.js. If I was to do this from scratch, I would probably use Scala.js. Yeah. Mm-hmm. Any other questions? Yeah.
Hold on. Let me get to you.
Sure.
How have you made decisions about topics to teach or not teach?
We follow the benevolent dictator model, so I get to decide anything that has to do with that. I taught the Liban training courses for a few years, so I have a good idea of a progression that I think works for newcomers, and that was it. Our target for the game, and I should probably mention this at the beginning, our target are people who know how to code, they just want to learn the language. So we're not teaching people how to program. We don't teach them what a loop is or what I/O is. We expect that they know that. We don't make any mention to specific language backgrounds, so we don't say this is like Java X or Java Y. But obviously that makes it easier. Yeah.
Is there a target age range?
Sorry?
Is there a target age range? Is it all adults or?
Age doesn't matter as much, but definitely the background, having some programming background. We are not immediately targeting schools or universities, although, again, university students who've already done a bit of programming can perfectly jump into this. Teaching children is, I think, a very different sort of experience, and I'm not sure this format would work great, but it's something I'd definitely like to look into later. I think there was another one. Yeah.
Can you repeat every question? You have to redo that.
Sure.
Okay.
Would it be possible to demo a little more how users are prompted to code something and how they enter it?
Sure.
Or are you not ready for that? That's just if possible.
Yes. So yeah, I can do a bit more of a demo and maybe start from level 1. Why don't we leave that for the very end so that people who want to see it can stay. Are there any other questions besides demoing? Yeah. How do I get an account? Okay. Yes. How do I try it? So it's not public yet, but it will be in the next few weeks. So right now, follow us. Sorry? It will be freemium, so you'll get to try it out. Yes. This is meant to be a self-sustaining project. Yeah, okay. So we want licensing. We want to sell licenses for this.